Nice to meet you. This is the Hobby IT channel. Thank you for watching today. In this channel, it is a video that challenges making things with IT. Programs and circuit diagrams are available on the website below, so please make use of them. Let's have fun together.
This time, I would like to do an electronic work called LED blinking that repeats turning on and off. The LED flashing is the most basic content and is the first thing to do when starting electronic work. Therefore, I would like to make the content as easy to understand as possible for beginners. I would like to proceed from the table of contents. Here is the table of contents. First, I would like to proceed with the outline, the circuit diagram, the wiring diagram, the software, and the operation check. I would like to move on to the next overview. Regarding the contents of the L blinking, this video is complete. However, this time it will be a series in which we will eventually create a smart remote control, and we will distribute it in a total of 7 videos. This time it will be the second LED electronic work. For those who want to understand only the L blinking, please understand that this flow is not related to the contents of this video. Now, let's move on to the next step, but this time we'll briefly review only the main points of the overview. First, for the development environment, we will use Arduino. It is widely used around the world for learning about electronic crafts, has a wide range of functions such as libraries, and has many learning materials on the internet, so you can learn effectively. Therefore, we will use it again this time. Move on. Regarding the selection of microcomputer, we will use ESP32. This is because they are inexpensive and have excellent features and performance. It has Wi-Fi and is highly versatile as an IoT terminal, so we will use it this time as well. Move on. There are various types of ESP32 development boards, but there are 2 main types, Aurum and Rover. The big difference is the difference in memory capacity. Aurum is fine for most uses. When handling videos, etc., memory is consumed, so please select Rover and use it. We won't be dealing with videos again this time, so we'll use Aurum. I don't think that other companies' products are suitable for beginners, so I won't use them this time. However, there are many things that can be used normally, so I think that it is inexpensive and there is no problem even if you use it. Move on. It becomes a breadboard. There are 6 holes on each side. As you can see from the back side, the 6 in a row are conducting. Therefore, the wiring stuck in these 6 holes is conducting. Wiring will be done using that continuity. The 2 vertical columns are also conducting in the same way. Next, let's talk about breadboard selection. When using the ESP32 development board, the left one is hard to use because there is no space on one side. Also, the mini breadboard cannot be used because it does not stick. Therefore, we will use the one with 6 holes and 30 rows on the right. This is just an overview, so I've kept it simple. From the next, it will be a circuit diagram, so I would like to check it in detail. Here is the circuit diagram. The wiring is done to light the LED, but the power supply is the operating voltage of the ESP32, which is 3.3 volts, and the forward voltage of the LED is 2 volts. So a direct connection would overload it and destroy the LED. Therefore, the resistors are wired in series. Regarding the value of the resistor, the voltage applied is constant from the LED specification, so the voltage across the resistor is 3.3 volts from the power supply minus the LED voltage of 2 volts, which is 1.3 volts. Since the current is connected in series, the LED and the resistor both flow in the same way. So, 1.3 volts divided by 20 milliamperes equals 65 ohms. This time, 65 ohms was too bright, so I lowered it to 200 ohms to reduce the current flow. I don't think it's a problem to use resistors larger than the calculated values. Note that reducing the resistance will destroy the LED. Next, we will perform wiring according to this circuit diagram. Here is the wiring diagram. I don't think such a wiring diagram is necessary because the wiring to the breadboard can be reinserted many times. I think it's common to wire directly to the breadboard while checking the circuit diagram. I made a wiring diagram to make it easier to understand. This time, IO22 is used for the LED. 3.3 volts is output from IO22, so it is wired to the LED via a resistor. After that, it is wired to connect to the ground. Next, let's check how the current flows. This shows the current flow from IO22, through a resistor, through an LED to ground. As a program, when IO22 is set to high with digital write, current will flow. Now let's wire it up on the breadboard. Here are the parts that will be wired. It's running at 3x speed. First plug in the ESP32 development board. Next we will wire the resistors. Try inserting it into IO22, roughly measure the length of the resistor leg, and bend it with radio pliers. Cut the length of the leg with nippers. Insert the resistor along the wire. Next is the LED, but since the legs are long, they are cut off. A positive current flows from IO22 of ESP32, so insert it so that it becomes the anode of the LED. Next, we will wire the ground. Wire from the ground port to row 24 on the breadboard. This allows the ground to be removed from the 24 holes. Finally, wire the LED cathode and ground. Measure the length and fold it. I cut it with a nipper and peel off the skin. Insert it last. Now that it's done, let's create the software. In creating a program, we will check the basic specifications of Arduino. Arduino has two functions whose roles are predetermined. There are two functions, the setup function and the loop function, and it is necessary to understand the contents. First, the setup function, which is the first function executed at startup. This function is executed only once at startup. Therefore, things that need to be done only once at startup, such as port settings and Wi-Fi connections, are executed here. Next is the loop function, which will be executed repeatedly while the device is running after the setup function is executed. It's easy, but as long as you remember this first, you'll be fine. Now let's create the program. Here is the Arduino IDE. I downloaded it from the official site and installed it. The latest version of Arduino IDE is the second generation, but we will use the first generation, which is one generation ago. It's not related to LED control, but it's because I didn't get it to work well with some functions. The version used this time is January 8, 2019. Since the program is basic, I would like to create it from a sample. Please select a sample like this. A sample sketch is created. As a reference, in Arduino, programs are called sketches, so please think that programs and sketches have the same meaning. Here is the sketch that was created. This time, we will use IO22 for the LED, so let's define the LED first. Since this value does not change in the middle of the program, it is defined as a constant. Also, microcomputers in particular tend to run out of memory, so we define bytes that consume as little as possible. Byte can be defined from 0 to 255 in 1 byte. Byte is used because it requires 2 bytes. Next, rewrite the contents related to pin control to the defined variables. There are 3 places, so I rewrote them all. Next, we will make it so that the operation is also displayed on the serial monitor. First, start the serial monitor. Next, after the LED is turned on and off, the execution is displayed on the monitor. The software is now created. Save the created software. If you don't save, everything will be lost, so don't forget to save. Finally, check the contents of the created software. Since the setup function is executed only once at the beginning, I set the serial monitor start processing and LED pin output settings. As for the loop function, it repeats during startup, so the content is that the LED repeats on and off every second. Now that the program is complete, we will write to ESP32 next. We will write the software. At this time, there is a high possibility that various errors will occur, so we will check in detail. First, wire the IO0 and ground of the main unit with a jumper pin. This is because writes often fail if IO0 is not grounded during writes. The ESP32 development board does not originally need this wiring. It may be compatible with a personal computer, but it may not go well, so I will wire it. Next, with the serial monitor displayed, press the N button to restart and confirm that it has started in the writing state. I also do this just in case. Next, in Arduino IDE, check if the settings such as board and port are properly selected. Port will be the port to which the ESP32 is connected. If you can confirm the settings, press the right button to write. The status will be displayed, so check it. Compilation is first performed to create an executable file of the software. Think of the compilation as rewriting into a machine-friendly language. Writing starts automatically when compilation is complete. When the writing is completed, it will be displayed like this. If there is an error, the contents of the error will be displayed here, so please take appropriate action. Since writing is completed, remove the jumper wire that was wired to ESP32. With the device removed, press the N button to restart. As written in the software, when restarted, the LED repeats turning on and off every second. As written in the program, the serial monitor also displays the status when turning on and off. If you can confirm that the LED is on and off in this way, it is complete. That's it, all the electronic work this time is over.
We will continue to take on the challenge of making things using IT like this, so please give us a high rating and subscribe to the channel. See you next time.